Now, up until now, we just had short examples that just ran quickly and you didn't have to wait. But in the reality is a bit different. If you run, for example, a big genome assembly, it will not be finished immediately, rather the opposite. So sometimes you will have big jobs, and if you have big jobs, the queuing time will be longer, and the job can run for days, and it's a bit bad because if you have to just stay logged in into the front end, then at some point your internet might die if you're logging in from home, or even if, I mean, also our internet isn't perfect, so there might be a disconnect. And so this is not ideal. Or, for example, even our front ends aren't perfect either, so they may crash. So yeah, that's not ideal. So you could work around a bit of that by using screen, but my example with a crashing front end, well, if your front end crashes and you run your program using srun in a screen, the job progress will be lost. There is a better solution for non-interactive jobs, and this is essentially the main way to use HPC systems, that at least traditionally. And these are batch jobs. Batch jobs is basically just a small shell script, bash script, or even something else, that have a special comment section. So inside bash, you have the hash sign as a comment. So each line that begins with a hash sign does not get run by bash itself. But schedulers can use this and say, okay, we will, if a line begins with hash and then sbatch, then Slurm will interpret it for you and say, okay, you can add now sbatch, and then add options that you usually would add to srun on the command line. This means you can add, for example, -p medium, 10 minutes. This one, the job output. Oh, I'll come to that soon. And yes, in this case, this would get handed to the Slurm, and it would evaluate it and use it as your resources for as the resource requirements of your job. Importantly, in this case, the sbatch lines have to be the first in the script, as it says here. So first you have this one. This is a shebang line. I think, as I said it already, that has to be at the top. Then there can be empty lines and other comments, but there is not supposed to be any commands. Then, so the first real, these sbatch things have to come before the first real command. Oh, sorry. Ugh. And then you can run your programs. In this case, I just had a srun Slurm resources again as an example. And this is essentially then a text file. Let me copy that, and I will now go back to my terminal. And I'm sure I still have a file called test.sh. Now let's have my job script called test.sh, and I have pasted in there these options, and I will also add reservation equals SCC course, and then Slurm output. So this sets the partition, this sets the time it's maximum supposed to run, this says where is the output gonna go, because you'll see why we need that soon, and the reservation, as you know, and then the usual Slurm resources. Now I can use the command sbatch to actually run this. Sbatch test.sh. And nothing else happened than this. What the hell? And this is where this comes in. So I usually expect my program Slurm resources to print some stuff onto the command line. And all that goes onto the command line usually will now go into this file, the job dash, and then this stands for the job ID. So it creates a file job-jobid.out. And if I now look into job-97 blah 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 .out, you can see some extra information and the usual Slurm resources output. I can leave it out as well. If I don't have this, the usual, if I don't specify it, it lands at slurm-job ID. The same again. So you can essentially ignore these parts for now. These contain just extra statistics about your job. As you can see, my job ID, my user name, the account I'm using, I'm admin, partition, node list, then the output of the job, and then some information. When it submitted, started, ended, how long it ran, how many CPUs, how many nodes, and we'll come to the profit stuff later. Okay. Now, right, I submitted it with sbatch, and yeah. So how does a job script usually look? So a job script can be essentially anything, just a normal script with a few extra lines in the beginning, but you don't even necessarily need them. Usually you use either bash or sh shell, but you can also use R or Python or Perl. As I already mentioned, the sbatch lines need to be at the top, otherwise they will not be evaluated. And the mean part is, Slurm won't tell you, because it stops reading the file as soon as it encounters the first non-comment line. And you can essentially do anything in there. So you can copy files from your home to Scratch, you can load modules, you can do some extra scripting, anything you want. And if you want to use MPI, if you're using MPI, you can run your program with srun or MPI run. Yeah, so how does the command itself work? You have sbatch, your Slurm options. You can also add Slurm options here. So you could add reservation dash reservation SCC cores here as well. You don't have to put it into the Slurm script. And as a matter of fact, everything supplied on the command line takes precedent over anything in the Slurm script. But apart from that, you can add options like mail. You have the option mail type. You can tell Slurm to send you some extra notifications. So, for example, if it's going to be a longer job, it might not run immediately. So you can say, okay, type begin, type end. So you get emails when it begins and when it ends. By default, it goes to your user ID at gvdg.de. If you don't have such an email address, you can just give your whole email address here. And the output and error file, if you just say output, so yeah, you can store the output of the job into a specific file. The %J stands for the job ID, but there are different options there as well. You look into man page for that. Since we just had that example, I want to have vim test sh. So what I could do here, wait, I want to have sbatch -- mail type. I mean, you won't see it because I'm getting the mails, but could have begin and end. And I could have mail user equals, I don't actually need that because I have mboden at gvdg.de, but Boden at you can add an email like that. And what I'm also going to do, just to show you, is sbatch, and I'm going to say partition fat. Oh, but that won't work. Wait. That will work soon. I'm going to remove the reservation. Now, sbatch partition fat and test.sh. So I've submitted the job, and now there should be a Slurm. takes a while. Okay, it takes a small moment. Ah, I got a mail. It seems to have started and ended. Ah, and indeed it did. So yeah, other just texted me I should swap the scenes, the usual. So I've added mail type begin and end to this and removed the reservation thing. The thing is, in here I have partition medium, but I submitted it using sbatch partition fat. And what you can see is that if I now look at the result, it went to the fat partition, just to show you that the sbatch parameter on the command line here take precedence over the content of the script. Okay, yeah, just from now on, all my scripts will have, all my examples will have Jobscripts, because this is what you usually use when you do HPC, because you usually don't have something that runs just for 10 minutes or something. So yeah, here's an example, just more examples of Jobscripts, which with which I also want to show something else. So this is an MPI job, and this one says, okay, go to the medium partition, send, create 240 tasks, and put the output somewhere. First purge all modules, and then reload the modules. Why am I doing that? Because this basically ensures that you always have only the modules down here loaded, and not some other things you did on the command line. So this helps reproducibility. And you run an MD, which is a software. I'm not sure what for what. I think some chemical stuff. Anyway, what happens now, this task will spread among however many nodes necessary. So it won't be contained to like 10 nodes or 4 nodes or something. It might run across 40 nodes or 96 nodes or something, which as opposed to this one, which is essentially the same, I mean, pretty close. But this one says, okay, give me 10 nodes and use 24 tasks per node. And the rest is the same. Why am I doing that? Because if I'm staying, so what you want to try if you're using MPI, this is, I mean, half of you know, like 80% of you can ignore that, but if you are running an MPI job, try to put it onto as little nodes as possible. Or at least don't spread it too far, because if you are running, if the MPI processes are communicating within the node, they will use memory to communicate, not network. And memory is very much faster than network. So you should spread your tasks to as little nodes as possible. If you don't use MPI, just ignore whatever I just said, because you're gonna you have a single task anyway. Now, which is more important for you, is jobs disk space usage options. What a nice title. Just a second, please. So we have a bunch of different places where you can store data, or not really store data, but have data. The first one is /local. /local is a directory on the hard disks of the node, of the actual node. So not some network file system, but actual SSD-based hard disks on the nodes. It's very fast, you can't break anything, essentially. Once your job finishes, all the files you had there were deleted, so you need to make sure that you copy any results back to to some other location beforehand. But this is extremely nice if you have if your program writes lots of temporary data that you don't need after the job, and sometimes this creates lots of I/O and lots of writing and reading, and will slow down your job. And the SSD is extremely fast for that. So if you have something like that, you can use the local disk, and we even automatically create a directory at $TMP local, so temporary local. Then we have a shared scratch space, which you already got to know. So we have two different scratch spaces here. The older one is scratch 2 and the newer one is scratch 1. It is quite fast. There is no automatic file deletion, no quota or anything, but also no backup. So it's not perfectly safe, let's call it that. Files may have to be deleted, as I said. If we want to run out of space at some point, we might ask you kindly to remove some files. But also, this is a shared space. So if you have a program that just hammers our file system with reading and writing all the time, some programs are quite bad at this, it might degrade our performance, and we will write you to please stop that. And so if you have such intense operations, try to use local disks as possible, if possible, or fix the program. Yeah. Additionally, we have, since, I don't know, a month ago or something, or 2 months ago, we have Scratch SSD, which is a special extra fast Scratch system, so it's shared, only available on Scratch 1, but it's ideal for temporary data that spans multiple nodes. So if you have a program that runs on multiple nodes, so MPI job, again, I guess most of you don't have that, but still, I'll have to say it. Or if even if you have just a normal a single node job, but your temporary data is bigger than the local disk, because the local disks aren't huge, you can use this Scratch SSD, and there is again automatic file deletion. So everything that isn't removed after the job ends will be deleted by us, so please move it back to your home directory or somewhere else on Scratch. And again, there is a per job directory created at this local variable. So in this case, by the way, it's /local /jobs/job ID, and in this case, it's /scratch/ssd/jobs/job ID. So you can also, it's quite easy to find it, but yeah. And then last but not least, we have the home directory, which is your home directory, apparently. It's available everywhere, it's permanent, it does have backup and all the nice things. It's quoted, so if you need more space, you need to write us. But for more complex operations, this thing is slow, especially compared to the other options. So if you have lots of writing, lots of reading, think of using something else, because that might actually slow you down more than some slow CPU. Okay, so we come back to this. I've shown you this once before. This is a graphic where you can see, for example, which node has access to which Scratch storage. So all the nodes, currently it's quite easy, and it will stay similarly easy. Everything that is in every node that begins with an A, essentially, has access to Scratch. Every node that begins with a D has access to Scratch 2. But there is actually an error on this one. There's still the Fat Plus node that has with 2 terabytes that isn't on here at the moment, which has access to Scratch 1 as well. Yeah. Right. What I forgot here is this part. So you can use the Slurm parameter -c Scratch or -c Scratch 2 to say I want to have access, definitely want to have access to either Scratch or Scratch 2. This is kind of important if you're submitting a job from, for example, from the front end GWDU 101. This front end only has access to Scratch 1, and you submit it from the Scratch directory, and then it lands on a node that only has access to Scratch 2. It won't work. There will just be problems, because the whole working directory where you submitted the job isn't available on that node, so everything breaks down and you don't even get a nice error. So please make sure that if you come to the point where you're wondering, why doesn't my job produce any output and nothing happens and it's just failure? It might be if you submitting from scratch and writing to scratch and everything, and it runs on a different scratch file system, there might be a problem there. Okay, here's another example of how this might actually look in the wild. Again, I have the SBatch lines, 24 cores, 1 node only. I have Scratch, and okay, I want to have these are setups which are important for running Gaussian. I've been told. I've never run it myself, and Gaussian also uses this environment variable to determine where it should put temporary data. And since Gaussian produces a lot of temporary data, we try to put it so essentially this nice thingy here just says, okay, if this file exists and it is a directory, then please use this as the temporary file system. It should always be that, but why not be sure? If not, use the local file system and then just run the job. The good thing is if you use these temp variables, you don't have to do the cleanup yourself. In the courses up until now, I still had a part of cleanup here. You don't need to do that because we do that for you. Yeah, that much for as my example on how to use Scratch. Now I want you to do something. Please write a job script where you create a Scratch directory somewhere, just because so you have done it sometimes. Copy the data from your home file system to some data from your home file system to the Scratch directory, run a job with the data, copy the results back, and delete the Scratch directory. That's a bit more than we usually need to do, but I obviously forgot to update it since I've updated this slide, but not this slide. But it's a good thing to do that every once in a while. I have a bit of code in, I hope it's still there, in Scratch project SCC course. It's just a very simple, stupid Python program. Let's go there. I'm going to show you that. So, yes, it is here, and you should all have access. Since you all listen to Azad very carefully, you will know that these nice little thingies say that you can enter this directory and you can read this file and even execute these files. You're not, so my idea would be that you basically, this is essentially just a very simple matrix multiplication. It takes 2 arguments, the input path and the output path, and then uses NumPy to read it and does a matrix multiplication and saves it. Quite simple. And what you should do is basically, first of all, copy the matrix. I mean, just to be sure, just copy everything to your home directory. Maybe I'll create a folder for that, SCC temp, because I have too many different folders. And let me just no, wait. Does it do what I want to do? Damn it! That's what I feared. I just wanted to have the files itself. I should have done this, but I can now. Okay, now in my home file. So what you could, as I said, copy this, the contents of this folder. I accidentally copied the whole folder itself, but copy the contents of your folder somewhere into your home directory. Now, what you should do is create a directory somewhere on Scratch, copy the matrix.csv to there, run the script. The script you can run, you first need to load the Python module, load Python, and then you can just do and out.mat, CSV, I think, right? And then you have this beautiful piece of text. But you're not supposed to do this in your home files, in your home directory, but instead copy the CSV file onto Scratch, run that shit, write the output onto Scratch as well, and then copy it back, and do all that inside of a job script. I think that's hopefully what it says on here. If you have your own program you want to run, feel free to do that as well. It might seem a bit tedious, like copying it back. I know it's kind of pointless with that, like a 1 megabyte input file. I see that. This is just an example. I don't have any better examples. If you have any, please let me know. But nevertheless, if you have any questions, ask them now, and I think we will combine this with a 15-minute break, maybe even 20-minute break. Although let's be back here at 55. I'll be back here earlier to answer questions anyway, but I'm gonna get a coffee. But I'll stay. Okay, start doing this exercise. I'll stay here for first questions, then I get a coffee, and we'll resume at 55. Okay, it's 55, so let's go on. I hope you've all been able to play around with this, and I will now show you what I had in mind. So, I have here my script as well as the input file. What I want is I'm going to create a run script.sh. Let's call it Jobscript. I always call it Jobscript. Jobscript.sh. I have first bit bash, then sbatch means -p. Oh, let's lose medium as dash reservation equals SCC course. Sbatch dash, yeah, why not? Let's use 4 cores, although, I mean, it's not that it's such a complicated program, but... And obviously I want to have... I definitely want to have access to Scratch, because that's where I want to put my data. And now, if I remember, so the idea was to create a Scratch directory, copy the data there, run the job, run the program, copy the result back, and delete the Scratch directory. So I'll first create a Scratch directory. How about Scratch users Boden SCC course TMP. And then I copy the file matrix.csv, which is in the directory where I'm gonna start this in this directory here. So this is gonna be fine. I can just say that and copy it to here. So I copy the file into the Scratch directory, then I run what was the name? matmult.py, and the input file is this, and matrix.csv, and the output file is supposed to be also going to Scratch, and it's going to be mat.out. And then I want to copy this file back to where I am. This is the dot says the current directory. I could also type it out to home SCC TMP. Yeah, that's the directory I'm in, right? Yes. And rm-rf this directory. And I think that, no, not quite. What I forgot here is module load Python, because I need Python 3 at least for this. And now I create the directory, copy it there, do the calculation on the data in Scratch, copy it back, and remove the temporary directory. Let's see if that works. There is a slurm file, and so this is the output of the script, of my Python script, and I have mat.out here, and this is again a very beautiful, just a CSV file. Okay, I don't really care about this, and I also don't care about this. So nowadays, because we've all these fancy variables already, what you also could do is, so we don't really need to make our own temporary file anymore. So what we could do is just say, okay, how about you copy that to tmp scratch. You could also use tmp local. Then say scratch/matrix and tmp scratch/mat-out, and then copy this all to tmp from tmp scratch/mat.out to my directory, and I don't need to delete it afterwards anymore because it's automatically deleted. Let's see if that works as well. Just as a reminder, I've removed the output sbatch Jobscript.sh. Okay. And it ran again, that's good. And the output is here as well. Oh yeah, no, that's not the output. That is... yeah. Okay. One more thing, just because I can. The way I've done it now was that I started from this thing, and so I gave the whole path, the whole path to matrix CSV. What I could also do is after this just say change directory inside the Slurm script into tmp scratch, and then just do this again. Now I have to think. So now I'm inside the tmp scratch directory. So I need to give the full path to my Python script, but then I don't need the full path to the matrix multiplication programs anymore. So this was SCC tmp, and then I need in the end obviously to copy this back to SCC-tmp. This should now work the same as before. I don't need to leave again because that happens automatically when the job ends, because the shell is killed. Jobscript. Again, I've removed the matrix files, the output. I hope all the questions are currently answered, because Azad is doing a great job. Yes, using this time without the full path as input file and as output file, and I still have the output file here. So this worked as well.